Hello, welcome to Elite Math Studio. Today we will be going through Secondary 1, the second chapter, called the real numbers. In this chapter we will learn about real numbers, we learn about rational numbers, inequalities, integers, and we'll do approximation and estimation. Okay, let's start the lesson. So the first concept of today is actually knowing what are integers. First concept of today is actually knowing what are integers, rational numbers, irrational numbers, and recurring decimals. So what are integers? Integers are actually just whole numbers. They are just whole numbers. For example, 1, 2, 3, 10, 31, 50, 69, -2, -7, -9. Okay, next one, what are rational numbers? A rational numbers is actually a number which can be expressed in a ratio. In other words, can be expressed in a fraction. So some rational numbers can be 1.1, 1.5, 2/7, 6. Why 6 is actually a rational number? Because it can be expressed as 6/1. 6/1. Okay, next one, for example, 7/11, -1.1, -3/8. Okay, that's what we call as rational values. Can be expressed into a ratio or fraction. All integers are rational numbers. Next one, what's irrational numbers? Irrational numbers means cannot be expressed in terms of a ratio or fraction. So what are some of the examples? Like this, square root -3. So when keying square root -3 into a calculator, it cannot be put into a fraction. So hence it's not as a irrational value. Pi. Why? You key in pi into your calculator, it will not give you a rational value as well. Okay, then we have, for example, cube root of -7. A cube root of -7 is actually a rational value. So we have another one, maybe say square root of -8. So square root of any negative numbers are what? Irrational numbers. So as long as you key in the calculator, it cannot be expressed in a fraction. It's a irrational numbers. Next one, what are recurring decimals? Recurring decimals are actually decimals, yeah, so for example like that, 1.111111111. These are called recurring decimals. They will have never endings one. So how do you actually express it? The answer will be just 1.1. A dot. We have a dot on top like that. Okay, next one, maybe we have 1.232323. So for this you can see the pattern is actually 12323. So what we do is actually the pattern is actually at 2 and 3, 2 and 3. So the answer is just 1.23, and then you put 2 dots on top of, you're going to put 2 dots on top of 2 and 3. Okay, that's the answer is actually 1.235, 235, 235, so on and so forth. So the pattern will be 235 and 235. So answer will be just 1.235. The first dot at the start of pattern, which is 2. The second dot at the end of pattern, which is 5. This is what I call as recurring decimals. Okay, can? So let's go to the next one. Consider the following: 1.8, 3.14, 3/5, this one. You need to so on and so forth. So we are supposed to list down all the integers. So what are integers? I hope you still remember. Integers are what is what we call as whole numbers. So our first whole number should be square root 16. Why? Because square root 16 is actually 4. Okay, next one will be cube root of 27. Why? Because cube root 27 is actually 3. Okay, and the last one is actually your 8. The next one, the question wants me to find, list down the recurring decimals. Recurring decimals. So what are recurring decimals? Let me see, recurring decimals. Recurring decimals, the first one would be 6.8 dot. The next one will be 1.68 dot dot. Any more recurring decimals? Let me see, there shouldn't be. Okay, can. Next one, list out all the rational values. You're going to list out all the rational values here. List out all the rational values. So rational values means the number can put in terms of ratio. It can be all decimals. All decimals are recurring. 1.8, 3.14. That goes for the same as fraction. 22/7. Square root 16 as well, because square root 16 is 4. 4 is actually 4/1. Square root 8. Square root 8, I don't think it's a rational value. Square root 8. No, it's not. Okay, next one, cube root 27. Rational will be 6.8 dot and 1.68 dot. Okay, can? Next one. So as long as the rational value means what number can be what? A rational you can put in terms of decimal or in terms of a fraction. Next one, you're supposed to list out all the irrational value. As long as it's not rational, it will be irrational. So the first irrational will be square root 8, comma. The next one will be cube root 12 and pi. Cube root 12 and pi. Because when you key all these values here in the calculator and try to put in fraction, you can't do it. Okay? Can? So the first exercise is actually to just try it. Next one is actually to try it. For this one, is actually trying to let you to identify what are integers, recurring decimal, rational numbers, and irrational numbers. Okay? Please give it a try. Next one, recurring decimals. So for this one, you need to actually arrange this in ascending order. Ascending order, I hope you guys know what's ascending order. Ascending order means smallest to biggest. So how are we going to do this? So let's try to put everything first. So right first 1.268 dot. This one you can express as 1.268, 68, so and so forth. Okay, next one is actually 1.268 dot here. So equals to 1.2688888. Next one, 1.268 dot. So will be equals to 1.268 dot. Next one is just 1.26. Pardon me, 1.268. Okay, so it goes to 1.268 dot 0. Okay, ascending order is actually smallest. So for this example, the smallest will definitely be 1.268. Followed by, let me see, will be 1.26. It will be this 1.268 dot at the 2 and a dot at the 8. Next one, it will be followed by 1.268, where the 2 dots are at the 6 and the 8. Last one, just 1.268 and a dot at behind. That's the answer. Okay, can I give you this one? Next two, try it. Same thing, you're going to express each of recurring decimals. Yeah, write on maybe the first 7 to 8 digits, and then you make a direct comparison. It should be okay. Can? Okay, let's try. Next one, number line. So next one, you're supposed to represent the following values on the number line. Okay, so let's try first. So let's try to put everything in decimal first. It will be easier for us. So this negative 8/5 is actually equal as negative 1.6, and this one is actually equals to 825, 875. Okay, so let's try to express all this into a number line. So number line, we have a 0 here, so we have -1, -2, -3, -4, and maybe -5. Okay, so this one maybe I just erase here. So it's actually your -5 here. Next one will be just 1, 2, and 3. Okay, so the first one is actually where's negative 0.5. Negative 0.5 should be somewhere here. Okay, So for right, by right you must write like that, then negative 0.5. And put across here. Okay, the next one we have 3.2. So where's 3.2? 3.2 will be somewhere here. So 3.2 and then put across here. The next one is actually negative 5.2. Negative 5.2 will be behind right here, all the way on the left. Okay, next one we have 8. 8 will definitely, yep. Okay, we cancel out 8 because, yeah, it's sufficient space. Next one, negative 8.8 over 5. Negative over 5 is actually what? Negative 1.6, so it will be somewhere here. Negative 8 over 5. Yep, the next one, we have 1.70. That one's actually somewhere here. Okay, can? Just like that. It's quite simple. Okay, so maybe we can actually write all the values on top. It will be nicer as well. Because right below a bit cramped. This is actually negative 0.5. Then the next one is actually negative 5.2. We can write on top. Yep, so these are actually all your answers. Here, 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 and here. Right here. Okay, can? The next one, I give you an example. So same thing. Try to express everything in terms of what? It's decimal. Then try to rearrange them on the number line, just like that. Okay? Spot there on the number line and then put a cross there. Okay? Can? The next one we'll be doing inequality. Inequality, we have what? We have signs like this. We have signs like this. So inequality, we have signs like this, which is this what we call as greater than, smaller than, greater than or equals to, or smaller than or equals to. Okay, so how to go and represent the following inequalities on the same number line? Okay, so let's try first this one. A, which is x lesser than, more than 9. So we draw a number line first, with an arrow pointing to the right. At the right hand side here you put an x. Okay, here you write 0, and here you put 9. X more than 9. So as long, now you have to memorize, as long as actually your signs are actually more than or lesser than, we'll use circle to denote. If it's more than or equals to, or lesser than or equals to, we use a dot. Okay, this is actually x more than 9, so draw a circle on top and draw it like that. X more than 9. Okay, next one, B, x lesser than negative 3, so same thing, draw it like that. X here, 0 will be here, negative 3 will be here. X lesser than 0, negative 3, lesser than, we use 0. If x is lesser than negative 3 means our values are what? Negative 4, negative 5, so all are smaller, so we go to the left instead. Okay, so means these are the regions. We are talking about these regions itself. For the second part, the region is actually here. Okay, let's try part C. Part C. The question asks me to express x more than or equals to negative 2. Denote where's a 0. Negative will be somewhere here. Then this will be x. More than or equals to, we use a dot to represent a dot. Should we go right or left? More than negative 2, more than or equals to, negative 2 means negative 1, 1, 2, 3, 4, so it's actually like that. Okay, so the values are like that. Just answer. Okay, part D. This one. X lesser than or equals to 8. So write 0 here. This is actually your 8. Lesser than or equals to. So same thing, you draw a dot. Lesser than or equals to will be something like that. Yep. Okay, the values here for this one will be just right here. Yep. Okay, so this is how it actually represents. That's how you're going to represent the inequality on the number line. Okay, so same thing, I will give you an example. Please pause the video and go and try it yourself. Next one, for inequality is actually a special rule. This actually will go to, this is supposedly to be learned when you go Sec 2 or Sec 2 or upper secondary, but maybe you try to do it this one. Okay, so the question asks you to say that solve the inequality and represent a solution. Okay, there's actually one rule here you have to memorize. Every time we multiply, or you divide by a negative number, by a negative value, you need to change the sign. So what do you mean by that? Let's say every time you times, multiply, or you divide by a negative number, a value you change the sign. Means what? More than will becomes lesser than. Lesser than will becomes more than, vice versa. Okay, let's try first. The first one, 2x is actually more than 16. So to find x, we need to what? Divide by 2 both sides. In this case, we divide by a positive number, hence signs will remain the same. So for this one, x is larger than 8. The question still asks me to represent it on a number line. So same thing, just draw a number line here. Draw it as x. This is 0 and this is 8. X larger than 8. So x larger than 8 is actually, the dot will be here. Larger than, go to the right. There's actually the region, like that. Okay, the next one, we copy down first. Negative 2x larger than or equals to 16. So to find x, we need to divide by negative 2. Okay, so what must you do? You divide by negative number, the sign need to be changed. So larger than or equals to will become smaller than or equals to. So x will just be smaller than or equals to negative 8. So same thing, just draw the number line. X 0, negative 8 will be on the left. Smaller than or equals to, because it's equals to with a dot, you move to the right, left, like that. Okay, this is actually the value. Next one, negative x more than 9. To find x, you need to divide by a negative 1. Do we divide by negative value? Yes, so need to change the sign. So for this one, x will be less than negative 9. Okay, so just draw it like that. X 0, negative 5 will be somewhere here. Smaller than, so you circle. Move right or left? Left. Okay, answer will be here. Okay, can? Same thing, I'll give you an example. So for inequalities, there's one special rule. Every time we times or divide by a negative number, the sign will need to be changed. The sign will need to be changed. Okay, can? Let's move to the next concept. Addition and subtraction of negative numbers. I think this one, yeah. This one, I think primary school, if your teacher teach you, you should know. But now, maybe you just try a little bit. What's 1 plus 2? I think 1 plus 2 is very simple. But this, yeah. So let me maybe explain to you in terms of number line. Will be easier later on when we do numbers. So just 1, 2, and 3. Pardon me. 1 plus 2. What number you start with? You start at number 2. Number 1, sorry. Plus means jump right. Remember, plus means jumping right, going rightwards. Minus, if you do plus means right, you go minus will be left. 1 plus 2 means 1, you jump right 2 steps. So that's why you land with what? 3. That's the answer for this one. 5 minus 2 is actually the same concept. What's 5 minus 2? 5 minus 2. Let me erase this one first, pardon me. 5 minus 2. 5, 4, 3, 2, 1, 0. What number you start with? 5. You move left 2 steps. So answer is actually what? 3. Next one, 3 minus 8. So what number do you start with? We start at number 3. You're gonna move left. How many steps? You're gonna move left 8 steps. So start at 3, you move left. So maybe draw a number line for you to better illustrate. You're at 3, you're supposed to move left 8 steps. From 3 to 0, it's already 3 steps. You need to move in total 8 steps to the left. So from here to here, you need to move another 5 steps. So where do you land? You land at negative 5. So that's the answer. Okay, applying the same concept, you make negative 2 minus 5. You're at negative 2 now. You need to move left 5 steps. So answer is actually what? Negative 7. Okay, if you keep applying the same concept, 11 minus 5. 11 minus 5 will be like that. This is 0, this 11. Pardon me. Let me draw again, sorry. You're at 11. You move left 15 steps. So from here to here, it's actually 11 steps. You're gonna move another 4 steps, such that you get 15. So what's the answer? -4. Okay, can? The next one, -2 minus 6, so same thing. 0, you're actually at -2. Minus 6 left 6 steps. So answer is actually what? -8. The next one, we have actually 3 numbers. The idea is actually very simple. You just have to what? You just have to solve 2 by 2. Okay? So let's try the first one first. -2 plus 8. So you're actually at -2, 0. -2 here. Plus means jump right 8 steps. So here you go 2 steps. And here you move 6 steps. So the answer is actually 6. Okay, so it will be 6 minus 3, which is just 3 itself. Okay, so in examination, imagine this all number line in your mind, in your head. You imagine number of line in your head, and then you ask yourself, should I move left or should I move right to help us solve this? Okay, I give you some examples. Please pause the video and go and try it yourself. If let's say there are 2 or 3, more than 3 terms, more than 2 terms means the expression of 3 terms, just do it 2 by 2. Okay, next one, we have some rules for us to remember when you do multiplication or division of positive and negative real numbers. So the first rule is actually this: positive times positive is positive. Negative times positive is negative. Positive times negative is negative, and negative times negative is positive. Okay, so let's try for this one first. The question, the first one, 3 plus -8. So the first step, we know plus and minus should give us what? You should know that plus and minus should give us minus, so it will be 3 minus 8, which is equals to just 5. Okay, next one, -8 minus -2, minus becomes plus, so it's -8 plus 2. So answer is just -6. Next one, -3 plus -10, so it becomes -3 minus 10, which is equals to -13. Next one, plus and minus will become plus and minus will becomes -8 plus 5. So the first one, what's -2? What's 2 minus 8 is actually equals to -6 plus 5, which is equals to -1. Okay, next one. The next example, you just take the number times number first. What's 3 times 2, which is what? 6. Now as a result, what's negative times positive will still be negative. Just like that. Next one, we try. Yes, so what's 2 times 3? 2 times 3 is actually what? 2 times 3 is actually 6. Negative times negative is actually what? Positive 6. The next one, take 10 divided by 2. What's 10 divided by 2? 10 divided by 2 is actually 5. What's negative divided by negative? Positive. Next one, 12 divided by 3 is actually 4. What's negative times positive is actually equals to -4. Next one, take 10 divided by 2. What's 10 divided by 2 is actually 5. Positive divided by negative is actually negative. Okay, next one, a few examples. -2 minus 5. This one, just imagine the number line in front of you. It's just actually equals to -7. Next one, 8 minus 13 is actually equals to -5 minus 2, which is equals to -7 as well. Next one, in the order operation, for this one you must do the multiplication first. Okay, so it becomes -2. -3 times -5 will be equals to -15, which is equals to -17. Okay, the next one, order operations, you have to do the square and the times first. 3 squared is as good as 9. -2 times -3 is actually equals to +6. Minus will becomes +5. Okay, so if you calculator, this one will be just 20. Next one, first step, we're going to do the squares, the cubes, and the times, all at one go. -2 the whole thing square is actually 4 plus, sorry, not plus, this is actually plus bracket -3 the whole thing cube is actually -27 plus bracket -16. Next step, you can see they have a lot of signs here. Positive and negative, positive. So it's actually equals to 4 minus 27 minus 16. Okay, so it becomes negative 39. Okay, all workings must be shown, so you must go through step by step. All workings must be shown. You must go through step by step. So next one, you do the squares. Okay, so let's do for this one. So will be equals to bracket. Will be equals to bracket 4 times negative 3 plus 8 plus 5 and then minus 3. Okay, can 4 times negative 3 is actually negative 12 plus 8. Okay, plus 5, the whole thing minus 3. Okay, the next step we can straight away go and simplify what's inside so that you can save some time. So it's actually equals to negative 12 plus 8 is actually negative 12 plus 8 is actually negative 4. Negative 4 plus 5 is actually 1. 1 minus 3, which is simply negative 2. That's the answer. Okay, can? So, yep. Use the rule. If the expression is too long, then you have to apply your order of operation. First step, do the brackets first. Or you can do the squares or the cube first. Next step, times or divide from left to right. Next step, plus or minus from left to right. Plus or minus from left to right.